right, so this is a semi-complete formal semantics for some of the features of the HPC. I'm not going to, as I said, I'm not going to go into complete details, and if this doesn't help, don't worry about it. It's there because it just might help. So the idea is that the meaning of a formula is an omega-array relation, and what that means, it's a set of omega sequences of elements from the domain of discourse of the interpretation side. So every formula denotes a set of sequences. You can think of in each sequence in there, x node is the value of circle 0, x1 is the value of circle 1, so you just collect together all these sort of value assignments for the circle pronouns that make it all work. Now, first of all, Boolean combinations, that's actually very easy because you use the set combinations corresponding to the Boolean operators. So, for example, if you're dealing with the disjoint of two formulas, the meaning of the disjoint, and I suppose I should put sign there. It's always with respect to a particular interpretation. So the disjunction of F and G denotes the union of the denotations of F and G separately. So disjunction corresponds to union. All the other Boolean operators have corresponding set operators. In particular, 0 is the empty set, and 1, and what I mean here is the meaning of 1 with respect to psi, is just a set of all possible omega sequences of elements of the domain of discourse. Now this is a huge set, but we're just thinking about it, we're not actually constructing it. Application is probably one of the, like all of these, a little bit mysterious. Suppose you have a variable x in a formula f, and you want to know what relation this application denotes. Well, it's the set of all sequences of the form for which if you stick the value of x on the head of this sequence, you get something that's in f itself. Abstraction, it gets too technical. I'm not going to do this right now. Universal generalization, here's a simple case to keep the complexity under control. F is a formula. Box F, the meaning of box F, given an interpretation of psi, is the set of all sequences such that whenever you take any individual element and stick it on the head of the sequence, you get something that's in F itself. Diamond is the dual of that. It's the set of all sequences such that by sticking something on the head, you can get something that's in F. So that doesn't always have to work, but it should work at least once, and that'll give you diamond F. Slash G, the diagonal operator, is x0, x0, x1, and so on, where x0, x1 is in G itself. So it has the effect of duplicating the head element. Tilde G is x1, x0, where x is in G and has the effect of swapping the first two elements. And star G, it's a set of all things obtained by putting a random A at the beginning, just all of those. This, incidentally, is what this was discovered, and the crucial operation was discovered in the 30s by Tarski, and they called it cylindrification. Not obvious to you why it's called that, but that's cylindrification. There's also the shift meta operator. I'll talk about